Hello class, and welcome to today's algebra lesson, which is about graphing linear functions. By the end of today's lesson, you'll be able to graph linear functions using tables and graph linear functions using the intercepts. So we're going to start with graphing by table. We're only graphing linear functions right now, so everything that you have on your final graph should be a straight line. If something goes off, that means you need to go back and check your table. When you are creating the table, we need the x's, which is what we're plugging in, and then the y's, which is going to be our answers. When we pick out the x's, we need at least one negative number, we need to plug in 0, and we need at least one positive number. The easiest numbers to use are generally -1, 0, and 1. So now what I'm going to do is I'm going to take my x value and I'm going to plug it in. So the first one is -2 times -1 minus 3. If you want to show your work like I'm doing down here, that is totally acceptable. Or if you would prefer just to plug this into the calculator, that is fine as well. So -2 times -1 is 2, minus 3 is -1. So the first point in our graph is -1, -1. Remember, when graphing, your x points tell you left and right. Left is negative, right is positive. Your y points tell you down and up. Negative is down, positive is up. Then we go on to the next point. So -2 times 0 minus 3. -2 times 0 is 0. Minus 3 gives you a -3. So we're at 0, left and right, and then down 1, 2, 3. And then we plug in 1. So -2 times 1 is -2, minus 3 gives you -5. Again, you can go through and show this work, or you can do the work in the calculator and just write down the table portion, but you do need to have the table shown. So 1 to the right, and then down 5. The last piece we are going to do is connect those dots. You should be using a straight edge, whether it's a ruler, the side of a protractor, your notebook, a binder, whatever, but you do need to be connecting them with a straight edge. So we go through and we connect all of our points, and we connect through the entire graph. So when we have our line, we connect through our entire graph. And then we want to make sure that we have arrows on the end to say that this line keeps going. Our graphs only show a 10 in any particular direction, but we know that graphs can continue going infinitely long, so that is why we need the arrows on the end of our graph. Go ahead and try this one on your own. Once again, plugging in our values of -1, 0, and 1, we get our points of 3, 5, and 7. We graph, and then we connect with a straight line. There are a couple of exceptions for when we can use -1, 0, and 1 as our points. That happens when we have fractions. If I multiplied 1/4 times -1, I'm going to get -0.25 plus 3, which is going to be 2.75. It would be really hard on the graph to get an accurate estimate of where 2.75 is. So when you have fractions, instead of using -1, 0, and 1, we want to use numbers that are actually going to give us whole numbers. So we look at the denominator and we say, okay, what numbers can be divided by 4? Because this fraction means multiplying by 1 and dividing by 4. So instead of using -1, I'm going to use -4. I'm going to still use 0 because 0 can be divided by anything. And then instead of +1, I'm going to use +4. So our two values, instead of 1 and -1, we use the numbers that's in the denominator so that we know it can be divided out evenly and we will be dealing with whole numbers. So I'm going to start with 1/4 times -4. Plus 3, 1/4 times -4 is -1, plus 3 gives me a +2. So my first point on my graph is going to be -4, +2. 4 to the left, 2 up. Then I'm going to have 1/4 times 0 plus 3, which is going to give me an answer of 3. So my next point is going to be 0 left and right and up 3. And then my last point is going to be 1/4 of 4, which is 1 plus 3, which gives me an answer of 4. So my last point is 4 to the right and 4 up. So again, we used -4 and +4 instead of -1 and +1 so that when we did the multiplication by the fraction, it was going to give us a whole number. So once again, our last thing here is going to be to connect our points using a straight line, and it's a little bit difficult sometimes on the computer, so I'm going to go ahead and adjust this just a little bit to make it go through my actual points. And then we want to make sure once again that we have those arrows on the end to signify that this line keeps going and doesn't just stop in the window that we can see on our graph. Go ahead and try this one on your own. So this time we use -5, 0, and 5 because our denominator is 5, so we want things that can be divided by 5. When you do that, you're going to get the points of -5, -4, 0, -6, and 5, -8, which gives you that straight line with the arrows on the end. Last piece with our table, you'll notice sometimes our equations only have one variable. When that happens, we still, when we make our table, start with x and y. This one tells us that y is equal to -4. So that means that no matter what we pick for x, our y points are going to be -4. I'm going to plug in then my regular x points and say -1, 0, and 1. So when I put these on my graph now, I've got 1 to the left and 4 down, none right or left and 4 down, and 1 right and 4 down. So in this case, we end up with a straight horizontal line going across my graph at -4. So when it is just one variable, you fill in that number in its particular place, so in this case it was the y, and then you put -1, 0, and 1 on the other side. Go ahead and try this one on your own. So in this case, we fill in the x's as 8, 8, and 8, and then put -1, 0, and 1 in for our y's. We can also graph linear functions by using the intercepts. We learned last chapter that the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. In order to graph using intercepts, we need to solve for each variable on its own. So I'm going to start with x. To find the x-intercept, we pretend like the y doesn't exist in the equation. So instead of having the y there, we're going to say 0. We want nothing there is equal to -12x plus 36. Then it becomes an equation we need to solve. So I'm going to subtract 36 on both sides of my problem, giving me -36 is equal to -12x. And then I'm going to finish by dividing by 12 on, -12 on both sides to get my x by itself. And I get 3 is equal to x. So what that means is my x-intercept is at 3, 0. So my graph hits the x-axis at 3. Then I do the same thing, but now I pretend like the x doesn't exist, so I can solve for y. So I'm going to say 4y is equal to nothing plus 36. In this case, nothing plus 36 is going to give you 36, and then I can solve by dividing 4 on both sides, giving me y is equal to 9, which means your y-intercept is going to be at 0, 9. So I go ahead and graph at 0, 9. Once again, our last step then is going to be to connect our points with a straight line. And give me a moment just to adjust this so that our line actually goes through our 2 points. It's much easier when you're on paper using a ruler to get that straight line to go actually through your points. And when we finish that, we add our arrows onto the end once again to say that our line keeps going forever and ever. So we solve for x, and then we solve for y, and we put those 2 points onto our graph. Go ahead and try this one on your own. So first, solving for x, you eliminate the y, and you divide by that -1 to get x by itself, so we end up with -8, 0. Then we have 2y is equal to 8, dividing by 2 gives you 0, 4 as your y-intercept. Last piece here, graphing with the intercepts in a word problem. So a farm produces about 4,362 pounds of peanuts per acre. 1 cup of peanut butter requires about 2/3 pounds of peanuts. The function y equals -2/3 x plus 4,362 represents the pounds of peanuts remaining after x cups of peanut butter have been made. Graph the function. So we're going to start by solving for our x, which means that we put 0 in the spot of y, and that gives us -2/3 x plus 4,362. We want to get rid of that 4,362 by subtracting that on both sides. And when I do that, I get -4,362 equals -2/3 x. Then to get rid of that -2/3 x, I'm going to divide by -2/3 on both sides of my equation, which gives us just x on the right side. And when I actually do that division, it gives me 6,543. So my x-intercept is 6,543, 0. Now as I come over to my graph, it looks like we're counting by 800s here, 6,400, and I need about 100 more, so I'm just past that original 6,400 mark. Then I'm going to go back in and I'm going to solve for my y now. So I'm going to leave y, put the 0 in for the x, and I still have plus 4,362. So my y is 4,362 after I do my addition, which means I've got 0, 4,362. Over here, it looks once again like we are counting by 800s. So we're at 800, 1600, 2400, 3200, 4000, aka 4000. And then I'm somewhere in between, not quite halfway, little bit below that. And that's going to be my y-intercept point. Now, for these word problems in particular, this is the only time you are not going to put arrows on the end of your problem. Reason being, you can't go to the left, you can't go into a negative cups of peanut butter, and we can't go into the negative pounds of peanuts. So in these word problems, this is going to be the only time where you don't actually put arrows on the end of your graph, because there is a reason that you have to stop at those 0 values. Go ahead and try this one on your own. Solving for your x, you get 24, 0, and your y is 0, 60, so we connect those dots, no arrows on the end because it is a word problem. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.